DBMS, RDBMS, ORDBMS. Introduction. What is data? Data is a collection of facts, concepts, or instructions that represents information which can be useful for communication. What is a database? A database is a collection of organized data used to model an organization or even a process. Different types of databases can be found, like text files, spreadsheets, which are the most basic kind but with more troubles. Also, we have relational databases, which provides more benefits, and also distributed databases for longer systems. DBMS. A database management system is a collection of programs which extracts information from a database. This is a must for managing databases and helps the administrators in such tasks. Most of this software can run on small computers, but others require more powerful systems. Why use a DBMS? It's the easiest way to handle a database. Also, file systems have too many drawbacks, like the difficult to access the data, the redundancy, security is a problem, and the performance is very low. Features of DBMS. With the DBMS, you can combine data from different sources and you can reduce the redundancy. Also, the development of applications and maintenance becomes easier. Architecture of DBMS. This picture shows the levels a DBMS has. As you can see, there is the view level, the logical level, the physical level, and the data source. Let's see in detail each of them. The view level or external level. This level is closest to the users and is concerned with the way in which the data is viewed by individual users. Most of the users are not concerned with all the information contained in the database. Instead, they need only a part of the database relevant to them. The system provides many views for the same database. The logical level or conceptual level describes what data are actually stored in the database. The logical level also describes the relationships existing among data. At this level, the database is described logically in terms of simple data structures. The internal level or physical level is the lowest level of abstraction. Describes how the data is physically stored. At the internal level, complex low-level data structures are described in detail. The data source is managed by the operating system under the direction of the DBMS. Key terms in DBMS. A schema, which is the database structure described in a formal language supported by the DBMS. The database instance is a complete database environment. Mappings. We have conceptual and external mapping. The first one relates the physical storage with the logical record. The external mapping relates the names in the user's view with the conceptual schema. Data models. There are 5 types of DBMS. The ER or entity relationship, the relational, the object-oriented, the network, and the hierarchical model. ER model. The ER model is a representation of the structured data, and it was introduced by Dr. Peter Chen in 1976. The ER model would say that you're an entity and each phone number is an entity, and the relationship between you and the phone numbers is has a phone number. Diagrams created to design these entities and relationships are called ER diagrams. Key terms in ER models. Entity, as we said before, denotes an object in the real world and as such have physical existence. An entity has attributes. Relationship, also, as we said, between two entities could be a relationship, and this defines the model. Based on the definitions we have seen so far, here's a picture of an ER diagram using change notation. A student has name and age, and the course has ID and name. The relationship is that a student is registered in a course. Object-oriented model. The object-oriented model is a logical organization of the real-world entities. This model has constraints and relationships among entities. It also follows the basic object-oriented concepts like object, attributes, and methods. An object is an entity of the real world. An object is defined by his attributes and methods. Object-oriented concepts. A class is an object definition. It defines which attributes and methods an object will have. Also, a class has hierarchy, which is its parent, and also children or subclasses, inheritance. Relational model. This model was proposed by Dr. Edcott in 1970, and it views real world as entities and relationships. This model requires a normalization of the data and also concerns about structure and integrity, which ensures the correctness of data and operators. Network model. The network model was invented by Charles Bachman in 1969, and object types are denoted by nodes and relationship types as arcs. Also, it structures data as a tree of records, and a parent can have multiple children, and a child can have multiple parents. As you can see on the picture, is a network model of agents, clients, entertainers, payments, engagements, and musical styles. For example, agents represent clients and manage entertainers. Hierarchical model. This kind of model organizes data into a tree structure. A parent-child relationship is used to represent it, and each parent can have many children, but each child can have only one parent. Keys in DBMS. Simple key. A key which contains a single field. Composite key. A key which contains two or more fields. Candidate key is a combination of attributes that can be uniquely used to identify a database record without any extraneous data. A table can have one or more candidate keys. Primary key, a key which uniquely identifies a record in a table. This PK is usually the key selected to identify a row when the database is physically implemented and responsible for a table level integrity. Superkey. It defined in the relationship model of database organization as a set of attributes of a relation variable for which it holds that in all relations assigned to that variable, there are no two distinct rows that have the same values for the attributes in this set. Foreign key. An attribute or set of attributes that appears as a non-key attribute in one table and as a primary key attribute in another table. This will create a parent-child relationship, semantic or natural key, a key for which the possible values have an obvious meaning to the user, like the example proposed here. Normalization is the process of organizing the fields and tables of a relational database to minimize redundancy and dependency. Normalization usually involves dividing large tables into smaller and less redundant tables and defining relationships between them. The objective is to isolate data so that additions, deletions, and modifications of a field can be made in just one table and then propagated through the rest of the database via the defined relationships. Dr. Edgar Cott first proposed this process. First normal form, 1NF. A table will be in 1NF if the following conditions are satisfied. Only atomic values present in the columns of the table. pk should be defined for the table. All the values of the column must be dependent, and it should deal with redundancy of data. Let's see this example. The student table has problems because it does not protect data integrity and table does not scale well. As you can see, the columns subject 1 and 2 and description 1 and 2 make the data be redundant. Let's see how to make this table in 1NF. Now we have two tables, the student info and the student subject. With this modification, the tables are in first normal form. Second normal form, 2NF. A table is said to be in 2NF if the following conditions are satisfied. The table should satisfy the 1NF, no partial dependencies should be present, and it has to deal with redundancy. Let's see the example. The student subject table contains repeated data vertically. Also, the subject information does not depend upon a student. It depends on the concept of a subject. Now, the student subject table is divided into two tables, subject and student subject. Now subject has each definition with no redundancy vertically. Here's a summary of the tables we have so far. We have the subject, student info, and student subject tables. Third normal form, 3NF. A table is said to be in 3NF if following conditions are satisfied. The table should satisfy 2NF. There are no functional dependencies of non-key attributes, no repeating elements, and there should be no transitive dependency. Let's see the following example. The student info table has been modified to add the student address. The address info is dependent on the address ID field. So to comply with the 3NF, this table must be decomposed in two tables. We have now the address table and the student info table with the address ID column to identify its address. Voice code normal form, also known as BCNF or 3.5NF, is a normal form used in database normalization. It is a slightly stronger version of the third normal form. It was developed in 1974 by Raymond Boyce and Edgar Cott to address certain types of anomaly not dealt with by 3NF as originally defined. Fourth normal form, 4NF, is a normal form used in database normalization, introduced by Ronald Fagin in 1977. 4NF is the next level of normalization after voice code normal form. Whereas the second, third, and voice code normal forms are concerned with functional dependencies, 4NF is concerned with a more general type of dependency known as a multi-valued dependency. Fifth normal form, 5NF, also known as project join normal form, is a level of database normalization designed to reduce redundancy in relational databases, recording multi-valued facts by isolating semantically related multiple relationships. A table is said to be in the 5NF if and only if every join dependency in it is implied by the candidate keys. RDBMS. RDBMS stands for Relational Database Management System. RDBMS is the basis for SQL and for all modern database systems like MS SQL Server, IBM DB2, Oracle, MySQL, and Microsoft Access. A relational database management system is a database management system that is based on the relational model as introduced by E.F. Codd in 1970 at IBM. Tables. The data in RDBMS is stored in database objects called tables. The table is a collection of related data entries, and it consists of columns and rows. Remember, a table is the most common and simplest form of data storage in a relational database. Some advantages include easier database design, powerful database management system, and conceptual simplicity increases. Also, there are some disadvantages, like the RDBMS does not have enough storage area to handle audio, video, and images, and also the possibility of poor design and implementation. Relationships between tables. One-to-one. It means that both tables must have only one record on each side of the relationship. For example, if you're married, you will have only one husband or wife. One-to-many. Sometimes called master detail, it means that on one side of the relationship it will be 0 or more records. Many-to-many. It means that each record on both tables can be related to 0 or more records in the related table. Here on the picture, you can see the ER model we're going to use on this tutorial. The tables are person, teacher, student, course, and student course. The teacher and student tables have a one-to-one relationship with the person table. The teacher table has a one-to-many relationship with the course table. The student and course tables have a many-to-many relationship, which generates a third table called student course. Here you have the summary of the tables and its relationships. Also, you can see here some additional considerations. For example, on the teacher table, the teacher ID column is a PK and also a FK. Please review the next ones. ORDBMS. An Object Relational Database, ORD, or Object Relational Database Management System, is a database management system similar to a relational database, but with an object-oriented database model. Objects, classes, and inheritance are directly supported in database schemas and in the query language. In addition, just as with proper relational systems, it supports extension of the data model with custom data types and methods. Some advantages include allowing the programmers to start using object-oriented systems in parallel. Of course, one disadvantage is the complexity. Difference between DBMS and RDBMS. One difference is that when a DBMS complexity gets increased, one of the major problems is data redundancy, which at the design stage is not easy to detect. This is solved using normal forms on RDBMS. Database security. For every database vendor, this is a must and it's taken seriously. Some vendors use more complex security and others simpler, but you will always have an option at this matter.